Punch cards and magnetic tape. Punch cards were the earliest form of computer storage, dating back to the 1800s for looms and adopted by computers in the 1950s. Holes punched in cards represented data. They were slow, bulky, and held minimal data, around 80 bytes per card. Magnetic tape emerged in the 1950s and stored data on reels of magnetic tape similar to cassettes. Tape drives were sequential access. You had to wind through the entire tape to reach specific data. They're still used today for archival backups because tape is cheap and lasts decades. Modern LTO9 tapes hold up to 18 terabytes compressed. Floppy disks became popular in the 1970s. The 8-inch floppy held around 80 kilobytes. The 5.25-inch floppy in the early 1980s held 360 kilobytes to 1.2 megabytes. The 3.5-inch floppy from the mid-1980s held 1.44 megabytes and became the standard through the 1990s. Floppies used magnetic storage on flexible plastic disks enclosed in protective cases. They were portable and removable but slow and prone to failure. Data degraded over time from magnetic field exposure. USB drives and CDR-OMS replaced floppies by the early 2000s. HDDS launched in 1956 with IBM's Raymac, which weighed over a ton and stored 5 megabytes. Modern HDDs use spinning magnetic platters with red/write heads that hover nanometers above the surface. Rotation speeds are typically 5,400 RPM for laptops and 7,200 RPM for desktops. High-performance drives reach 10,000 or 15,000 RPM. Capacities range from 500 gigabytes to 20 terabytes for consumer drives. Enterprise drives reach higher capacities. HDDS connect via SATA for most consumer applications or SAS for enterprise servers. Mechanical components make them slower than SSDs, but much cheaper per gigabyte. HDDs remain the best choice for bulk storage where speed isn't critical. CDs launched in 1982 for audio and adapted for data storage by 1985. A standard CD holds 700 megabytes. CDs use laser technology to read pits and lands burned into a reflective layer. DVDs arrived in 1995 with capacities of 4.7 gigabytes for single layer and 8.5 gigabytes for dual layer discs. The shorter wavelength laser allowed denser data storage. DVDS became standard for movies and software distribution. Blu-ray launched in 2006 using blue-violet lasers with even shorter wavelength. Single-layer Blu-ray holds 25 gigabytes. Dual-layer holds 50 gigabytes. BDXL discs reach 100 gigabytes to 128 gigabytes. Optical media is cheap and stable for archival storage, but read-only discs can't be rewritten. Recordable variants like CDR, DVD-R, and BDR exist for one-time writing. Iomega's zip drives launched in 1994 as a floppy replacement. Zip disks held 100 megabytes, 250 megabytes, or 750 megabytes depending on the generation. They used removable magnetic disks in hard plastic cases. Jazz drives were higher capacity versions, holding 1 gigabyte or 2 gigabytes. Both formats were popular in the late 1990s for backup and file transfer but were expensive. USB flash drives killed them by the early 2000s and revolutionized portable storage. They used NAND flash memory with no moving parts. Early drives held 8 megabytes to 128 megabytes. Modern drives reach 2 terabytes. Flash drives are compact, durable, and hot swappable. They connect via USB-A or USB-C. Transfer speeds vary widely. USB 2.0 drives max at 480 megabits per second. USB 3.0 reaches 5 gigabits per second, and USB 3.1 Gen 2 reaches 10 gigabits per second. SD cards launched in 1999 for digital cameras and portable devices. Standard SD cards measure 32 millimeters by 24 millimeters. Mini SD and micro SD are smaller variants, with micro SD becoming standard in smartphones. Capacity standards include SD up to 2 gigabytes, SDHC up to 32 gigabytes, SDXC up to 2 terabytes, and SDUC up to 128 terabytes. Speed classes indicate minimum write speeds. Class 10, UHS-1, UHS-2, UHS-3, and newer standards like SD Express. The fastest cards reach over 300 megabytes per second read speeds. SSDs use NAND flash memory, like USB drives, but with controller chips optimized for sustained performance. The first consumer SSDs appeared in the mid-2000s. Early drives were expensive and had limited capacity. SATA SSDs use the same interface as HDDS, making them easy upgrades. SATA 3 Maxes at 600 megabytes per second, so SSDs typically achieve 500 to 550 megabytes per second read and write speeds. Capacities range from 120 gigabytes to 4 terabytes commonly. SSDs have no moving parts, making them faster, more durable, and more HDDs. Random access performance is dramatically better. SATA SSDs became mainstream by 2015 as prices dropped. M2 is a form factor, not a performance standard. M2. SATA SSDs use the M2 slot but connect via SATA protocol, limiting speeds to around 550 megabytes per second, like 2.5-inch SATA drives. The advantage is the compact size, no cables needed. M2 SATA is common in laptops and small form factor builds. The M2 connector supports both SATA and NVMe, which confuses people. NVMe NVMe stands for Non-Volatile Memory Express. NVMe drives connect via PCIe lane instead of SATA, removing the bottleneck. PCIe 3.0, NVMe drives reach 3,500 megabytes per second read and 3,000 megabytes per second write speeds. PCIe 4.0, NVMe doubles bandwidth, reaching 7,000 megabytes per second read and write. PCIe 5.0 NVMe drives are emerging with speeds exceeding 10,000 megabytes per second. Most NVMe drives use the M.2 form factor. NVMe dramatically improves load times, file transfers, and system responsiveness. Gaming, video editing, and workstation tasks benefit significantly. NVMe became mainstream with widespread motherboard support by 2018. U2 and U3 drives. U2 drives are enterprise SSDs using a 2.5-inch form factor with a different connector than SATA. They connect via PCIe and support NVMe. U2 allows hot swapping in server environments. U3 is the newer standard supporting both NVMe and SATA on the same connector. These formats are rare in consumer systems but common in data centers. External SSDs. External SSDs connect via USB-C or Thunderbolt. They offer portability with SSD speeds. USB 3.1 Gen 2. External SSDs reach around 1,000 megabytes per second. Thunderbolt 3 and 4 external drives can reach NVMe speeds of 2,500 megabytes per second or higher. External SSDs are popular for video editors and anyone needing fast portable storage. They're more expensive than external HDDs, but far more durable and faster. Optane memory. Intel Optane uses 3D XPoint technology, different from NAND flash. Optane offers lower latency and higher endurance than SSDs. Intel positioned Optane as cache for HDDs or ultra-fast storage for workstation. Optane came in M2 modules for caching and U2 drives for primary storage. Performance was impressive, but prices were extremely high. Intel discontinued consumer Optane in 2022 due to poor adoption. The technology showed promise but couldn't compete with rapidly improving NVMe SSDs. Network attached storage NAS devices are dedicated storage servers connected to your network. They typically use multiple HDDs in RAID configurations for redundancy and capacity. NAS provides centralized storage accessible by multiple devices. Popular brands include Synology, QNAP, and Western Digital. NAS is ideal for media servers, backups, and home lab. Performance depends on network speed. Gigabit Ethernet provides around 125 megabytes per second, while 10 gigabit Ethernet reaches 1,250 megabytes per second. Cloud storage. Cloud storage keeps data on remote servers accessed via the internet. Services like Google Drive, Dropbox, OneDrive, and iCloud offer convenience and accessibility from any device. Performance depends entirely on internet speed. Cloud storage works well for documents and backups, but poorly for large files or frequent access. Privacy concerns exist since data resides on third-party servers. Subscription costs add up over time compared to local storage. Hybrid drives. SSHDs combine a small SSD cache with a traditional HDD. The SSD portion holds frequently accessed files, while the HDD provides bulk capacity. The drive's firmware learns which data to cache. SSHDs offer a middle ground between HDD and SSD pricing. Performance is better than pure HDDs, but far below pure SSDs. They were popular briefly in the early 2000s,